Continuing our topic for differential calculus, we have a set of expressions from 1 to 6. Okay, so our objective is to acquaint ourselves by practicing how to calculate or how to simplify differentials, okay, and how to differentiate expressions, okay? So we have here from number 1 to number 6. So let's make this quick, right? Okay, so if, for example, okay, if I have so we're gonna use this in this particular differentiation. This is called the chain rule differentiation. Okay, get the point? So it already introduced to you the implicit differentiation, chain rule differentiation, okay, the power rule differentiation, okay, the rectilinear motion differentiation, okay, now chain rule differentiation, right? Okay, so how can we solve this one? Oh my god, my gosh, okay. Okay, so if we have here, see, uh, the derivative of a function of, let's say, uh, function g sub x, no? So this is the derivative of this whole thing g sub x, okay, times the derivative of the inside of the function gx, okay? This will be like that. Follow this rule already. And after this, you can apply it there, okay? You get the point. Okay, things like that. Okay, so number 1. So it looks like stage number 1, right? Okay. Y is equals to 2x squared plus 4x minus 3 raised to the power 199. Okay, do not be afraid with the exponent, right? So this is also chain rule, right? Okay. So the first thing to do, use power rule, and then this is our u or x, no? And differentiate that. Okay, so it's gonna be 199. Okay, so 199. Okay, and then the copy this whole thing, 2x squared plus 4x minus 3. Okay, and then 199 minus 1, 198. Power rule, diba? N minus 1. Then this is the variable x or u times the 100. Okay, so 198, and then this one also 198. Okay, now when you subtract by 1, you put that down beside the expression. Okay, then differentiate the n inside the bracket, no? This is 4x plus 4. Oh, as easy as that, right? This is 0. The derivative of 3, negative 3 is 0. So this one, 198 times 2x squared plus 4x minus 2 is to the power 198 times 4x plus 4. Okay? You get the point. Number 2. Number 2. Okay. So trigonometric functions. Magbigat again trigonometric functions. We feel differently, right? Because it's not the usual, okay? So d over dx. Okay, d over dx. So this one, sine tangent x plus 4. So this is your u expression, no? Things like that. You get the point. So that's gonna be, so the derivative of this whole thing, the derivative of d over dx sine u is equals to the cosine u, right? Tama ba? Yes, cosine u. So therefore, you will say cosine, then u, this thing, tangent, okay, cosine tangent x to the 4, right? Like that, okay? And then the derivative of the u, okay, which is the tangent x 4, not this one. So what is the derivative of tangent? Get the point? Tangent, tangent, tangent u. Diba? Tangent u is equals to secant squared u, no? Things like that. Okay, so, okay, secant squared u. Secant squared u. So therefore, that is secant squared, so x to the 4. Okay? Okay. We are differentiating this one naman. Okay, so we need to say secant squared, okay, u. So x to the 4, no? And then the inside derivative of u, because this is already the u of the second part, no? X to the 4th. So 4x to the cube. Okay? This is the answer. Okay? So we need to put like this, no? Like that. Cosine tangent x to the 4th times secant squared x to the 4th minus 4x cubed. Okay? Okay. So number 3. Okay. Things like that, no? Why? So why mean guys, dy dx ni siya guys, ha? The differentiation. So take note also, if we put d over dx, okay, that's direct. If we put y, that is dy dx. dy dx and d over dx is not the same. Right? So things like that. So we have here, so y is equals to rational expression, no? So 1 over x squared plus 8 raised to the power 3. Kinisha guys, this is a quotient rule, but this is not really a full-fledged a full-fledged quotient rule, because the numerator is only the constant. Okay, only one. So if it is 2x plus 3, also x minus 3, if this x variable, things like that, so it could be the quotient rule, but here only one. Get the point? So meaning to say, you will just use the inverse rule, no, of the quotient rule. Oh, inverse rule of the quotient rule. Okay, it's gonna be like, so you need to jump this denominator to the top. Okay, so this is gonna be x squared plus 8 raised to the power negative 3. Right? This is, first, this is inverse exponent rule in the law of exponent. Okay. Second, this is the quotient rule. Okay, also. See? At the point no. Okay. Things like that. And then you're gonna raise this denominator to the top. So that's where the exponent will become negative 3. Okay? Things like that. So, okay. So, meron siya. So, power rule na yun. Okay, get the point, no? So, negative 3 minus 1, the exponent, no? Negative 3 minus 1, negative 4. So, negative 4 x squared plus 8 negative 4. And then, what's the inside? So, x squared plus 8. Derivative of x squared is 2x. Derivative of 8 is 0. So, therefore, this is 8 negative 8x x squared plus 8 negative 4. So this is the differential of this number 3. Okay, get the point? Okay, any question so far? Okay, so direct, right? Tama ba? Direct, yes. Okay. Now this one, number 4. If you know the rule, guys, it's a little bit easy. Get the point? Okay, number 4. So 7 ln x raised to the power 6. If you can remember that the integral of 1x dx is equals to ln x plus c. Since this is differential, we'll say the derivative of ln x is equals to 1x. Because we will take only the antiderivative or the opposite. So that's why this is a differential. So all you have to do, if you only memorize one, you can reverse as long as you know how to manipulate. No need to memorize all the integral. You could either memorize all the integral and then you don't memorize the differential, as long as that is the reverse of the integral, to save time. But if you want really, because you don't want to analyze every time the reverse, for me, to be honest, you should also memorize the differential and an integral. So that you no need to put headache on your mind ba that every time you will have this one, you're gonna reverse. So it will take time. Okay? So as plastada na in your brain, so that's why it's very easy to differentiate and integrate. You get the point? Oh. So we have here. So 6 minus 1. Okay, this is 5. No? So 5. Yeah, the exponent will be 5 also. 6 minus 1, 5. Okay. You get the point? So your result of your exponent will be transposed to the downside beside the expression, you know, things like that. Okay, so this is still ln x, no? Copy. Okay, times the derivative of ln x. This one. So 1 times x. So 1 na siya. Okay? Or we can say 5x ln x raised to the power 5. Get the point, no? If you want to multiply that here, okay, things like that. So kalas, number 5. Diba? Right? So number 5, you have second 4x. So something second 4x is that, for example, that is the integral. Ako kasi guys, I memorize the integral formula and then I can navigate to differential. So this is secant x. So the integral of secant x is equals to ln secant x, no? Plus tangent x plus c. Okay, get the point? Things like that. Tama ba? Okay. ln secant x plus tangent x plus c. Sure ka? You get the point, no? Why you involve yes, there's an ln. Okay? Things like that. Okay, so we have here, so ang imong differential ani, okay, because this is your secant x. Ay, pabali na siya. This secant x tangent x is equals to secant x man siya, no? Sorry. You get the point? Oo. Diba? Okay, so atong gamiton, kani siya. Okay, kani number 1, no? Kaya balihon mo siya, muna siya niyang kuan. So, yung differentiation kani. Okay? So, kung i-differentiate na siya, mahimong second x. Mahimong siya differentiate kaya siya, mahimong ka na. Okay, the point na, oo. Okay? Second x man ta. Kita point no, oo, things like that. Kung kuan man siya, kung second x tangent x, di ba? Kuan siya, second squared x. Di ba? Di ba kayo mga palangga, di ba? O, itong integral of, let's say, cosecant squared, no? Cosecant squared x, di ba, is negative cotangent x plus c. Okay? So, secant squared x tangent x plus c, di ba? Okay, then if you say x tangent, secant x, integral of secant x tangent x, di ba, is equals to secant squared x. No? Di ba? Tama ba? Okay, get the point. Oo. Second. Okay? Secant squared x. Di ba? Kani. Okay? So, sa to pa, ang atong integral of secant x is equals to ln. Mula ito. Okay, get the point. Secant x tangent x plus c. Okay, secant pan siya. Get the point? Oo. Get the point? So, imo siyang, okay, secant man siya, dito na siya. Okay. So, ln secant x, okay, yeah, 4x man, so secant x 4x plus tangent 4x, okay, get the point, no? So what is the inner for x? So 4, so therefore 4 ln secant 4x Charlie. Plus tangent 4x. Okay? Diba? Things like that. Okay. Now, arita sa tangent x. Kita po ito. Things like that. So, tangent x. So, diba ang tangent x, integral of tangent x, diba? Okay. Okay, mo sa tangent x. Okay, diba? Naurma ito siya. The integral of secant x tangent x is equals to tangent x. Nakakaloka. O, diba? Okay, kita point. Kani ba? Kani? Okay. Kani siya. Okay. Oh, dili siya, guys. Wait, wala man siya secant. Wala siya. Sorry ha. Secant squared x. Diba? Tangent x. Kanira? Okay, kanira dahil siya. Okay. Oo, kanira ito gamiton. Okay. Sa to pa, secant squared, yun siya, secant squared, okay, then the whole thing kani siya, okay, tangent x cubed, no? And then the derivative of tangent x cubed, no? Kani mo siya, oh. So 3 secant squared tangent x cubed. Okay, because this is the u already of tangent, no? Of these two terms, tangent and x. Dili ni mo siya i-derivative ang tangent ng x, magbalik-balik ka, yung data point ng oo. Tama ba? Yes. Okay. Secant x tangent x. Okay. Oh, wait. 3 terms naman din siya. Tama. 3 terms, no? 1, 2, 3. Diba? Okay, kanina man siya imong u. Okay, so this is meaning u. So secant squared u. So imong kopyahon. Okay. Yan. Ang derivative po ng tangent. Ano yan? Okay. Paano siya? Tangent x. Diba? Oo. Diba? Sa ito pa, secant x tangent x. Ano po kayo? Secant x tangent x. Okay. And then derivative ni mo sa x cubed, 3x squared. Okay. So, muna siya may tabo. Okay. Okay, guys. Okay, things like that. Diba? Sarap eh. Diba? Okay. So, ang episode ni kanilang number 5. Okay, number 5. Sige, pwede ko na number 5. Okay. Diba? So, this is the u, no? This is tangent u. Okay, the derivative of tangent u. Okay, kita point on sama na siya. Okay, so that is, okay, secant x, tangent x. Tama ba? Okay. Wait. No, secant squared x lang. Ay, kung ano siya, opposite lang siya sa kuan. Okay, kita point no, okay, naman kung di ba, ito nga, diba ka nga, secant squared x, di ba? Tangent x integral, okay? So ito pa, yung differential, tangent x, secant squared x. Kita point no, okay, the reverse man, the antiderivative. So muna siya, okay, kita point, so secant squared, imong u is x cubed, no? Then 3x squared. So 3 secant squared x cubed lang siya, no? Kani. Okay, hindi mo na siya 3 expressions. Okay, unless 3 expressions siya may cosine diri. Okay, duha raman man siya. Okay, 2 only see the x cube and the tangent ra. Okay? So therefore ana siya secant squared x cubed times 3x squared or 3x squared secant squared x cubed. 3x squared ra. 3x squared secant squared x cubed. Muna siya. Okay? Okay. Sure na ba? Yes. Okay, get the point. Diba? Sa chain rule, guys, imong pagsatagsaon, you need to go one by one. Because sa point no, things like that. And then since you are differentiating the another one, composed of two terms, that's why it will be more, no? But here kasi two terms lang, tangent, x cube lang kasi, tangent u. Okay? Ganun. Okay, get the point. Pag sure, Okay, diba? Tama ba? Yes, sakto jud siya. Okay, get the point. So to pa guys, ang tangent di ay ang derivative sa tangent na ang kuan. Diba? Kung yung ka nga integral of tangent u. Diba? Okay? Things like that. Okay, kanina mo good siya guys. Diba? Second squared, ang imong integral. Second squared x. So ito pa, tangent x siya. Diba? Tanawa? Okay. Diba? Nakakaloka. Dito po ito. Yan po, second squared x. So ito pa, negative cotangent x. Get the point? Things like that. Diba? Tanawa. If you try to compare that here, see here. See? The integral of tangent u is equals to ln, ln second u, or that is negative ln, let's say, this is sine u. And also cosine u, cosine u. So, di ba? So, tangent pa sa good niya siya. But remember, this is integration. Okay? And then the reverse of this is this one. So it's confusing. If it start in this manner, ln second u, it negative ln cosine u, so you need also to say tangent u. The derivative of ln second u is tangent u. Okay? Then, so here kasi, see, this is the integral of secant squared x is tangent x, right? Therefore, the derivative of tangent x is secant squared x. Kasi dito kasi integral na siya eh. Okay? So you'll never use this. It's confusing a little bit, right? See? This one. Since our expression is tangent man siya, it's not in terms of ln. That's why we will use this one. This is the disadvantage if you are only memorizing the integral. So dapat pala memorize also the differential formula. It's not enough that you will reverse it. Just like this, I'm confused, right? Because there's also tangent x. There's also tangent here. Okay? So, yun lang. Ito point no, nakakaluka. Diba? So, kung kanipod siya, secant x. Ito point no, secant x. Diba? Muna po itong naikuan din nga. Integral sa secant x. Diba? So, diba? ln, dapat ln, diba? ln secant x plus tangent x. So, this is the reverse man. So, this is not the differential of tangent x. It's not secant x. You get the point? Diba? Things like that. So, ibig sabihin guys, is this tangent x. So, go to the relationship na check ka ng kuan tangent, no? Okay, get the point? So, if I will say, so tangent x equals secant x, okay? The integral of secant x tangent x is equals to tangent x. Alok. Diba? Things like that. Things like that. So ang imo, kung tangent imo, secant x tangent x. You get the point no? Diba? Things like that. Naka-J mo guys. You get the point? Things like that. Basta mag-squared gani ka, okay, imong ko ang tangent o cotangent na siya. Okay? Things like that. Diba? Things like that. Any questions so far for that? Okay. So, ano na siya? Okay. Oo. Diba? Ano lang. Okay. So, memorize na lang yun ang differential calculus para memorize all the formulas there because we are dealing with differential so that it will not be confusing. Hindi mo tagamhanan. Trying hard mo, kung gamhanan, di ba tagamhanan, di ba no? Things like that. Di ba? So try to think that if you try to reverse, it would be the expression given in that particular, equation so that you can really do. But the moment it will not be appearing in that the same manner, don't use it. Okay? Diba? Nakakalimutan. Ana lang. Okay, any questions so far? Yun lang. Thank you so much for that chain rule differentiation. Thank you so much for watching, Sir Bayanal. Hello. Bye-bye. See you later for my another topic. Okay.